Okay, everyone, good afternoon. How we doing?
Yeah!
Oh, wow, you're saying yay, Matt. Okay.
Good.
How you doing? Yeah, man.
That'd be a good answer to any question.
It would.
Excuse me, sir.
I had actually a yay math star sighting at Trader Joe's last fall.
What?
I was walking out of Trader Joe's, and this guy my age, he's like, "Yay math professor?" And I'm like, I don't think of myself as a professor, but yeah, yay math. And he's like, "Oh, very nice, very nice." And then he felt weird and he walked away.
He's like, how you doing? He's like, how you doing?
You're too much of a celebrity. He was too embarrassed.
It was
to be a
cool.
celebrity.
It was cool. It's like, we're helping people. So that was cool. I like that he called me the professor. And that I'm not changing too much over the years. That's another thing. So today we're going to be doing angles of polygons. It's actually pretty interesting. And I hope you learn a lot from it. I think you will. So let's start it off with what a polygon is. What does the word poly mean?
Many.
Many, right? So many. And then like gone. I mean, this is like a shape, a shape. This is like a sides or a shape. So we could talk about it, like, let's say if a polygon has 3 sides, what's that called? Triangle, very good, triangle. It's okay. Triangle.
God, bell pepper.
Where?
That's one kind of this.
No.
That's another kind. That's another kind. What is, you say?
Quadrilateral.
Quadrilateral.
Oh, like an
Quadrilateral.
ATV. That's what they call it a quad. Because quad means 4.
Yeah, or 4 quarters, right. All right, 5. What's that called? It's
Pentagon.
Pentagon.
Pentagon. Like, yeah.
Like the Pentagon, huh?
The Pentagon.
Hexagon.
Hexagon is right. So you want to write all these down so we get them down, get the vocab.
Mexico.
What's this?
Pentagon.
No, is it a octagon? No, that's 8. No.
Pentagon plus 2.
7 is a
Septagon.
septagon.
Septagon? Google.
That's what it is.
All right.
It's not Google.
Sure.
I think 9. Do you
Oh,
want
I
it?
lost Miss Pride.
Somebody shut it.
This is actually a nonagon.
Nonagon, yeah.
What's the prefix for 10?
Eat some snacks.
Decagon.
Decagon. Damn it, he won.
He's on it.
Damn,
11, there's no real
emergency
name. And then 12, finally,
Is it dosagon?
It's like a
dodecagon. Dodecagon.
Delicious.
Where's the
If you ate it, it would be
where do
delicious.
these
Yeah.
where do these come from? Like ancient Greece or?
It's Greek. It's
Yeah, this is Greek
roots.
origins. Yes, that's right. So
Isn't a
these
lot
are
of
the
like
shapes.
math from Greek?
Spanish.
We're keeping in mind, though, that all of these shapes have a certain characteristic. They're one of these two.
Agon.
Concave versus convex.
All right, let's talk about the difference between these, and then we're getting into the fun stuff. So concave sounds like it is. Yeah, exactly. Caved in. Caved in.
That's never
So
good, though.
any of these shapes that we see, we're not going to be doing studies on concave shapes. Even though this would be, let's say, 1, 2, 3, 4, 5. That would be a concave pentagon. But we're not really going to talk about it. We're only going to talk about what is not concave, which is convex. So convex pentagon, you can write it as an example for yourself. Pretty much looks like the pentagons that we're
Jillian, let's
accustomed
be
to.
writing this down.
Any questions about concave versus convex? Concave we're in, convex we're out. Okay. Now let's have some fun with angles.
Like that like button.
How many sides?
3.
3.
6.
Almost. That's 3. How many degrees?
180.
180.
Always 180. Always.
It's like 84 degrees.
How many sides in a
84
quadrilateral?
degrees.
4.
Now here's my question to you.
360.
If I needed to split it, good job. If I needed to split it, how many triangles could I create from this? Say it.
2.
2.
Well, you could create 4.
I could create 4, that's true. I could create 4.
Well, you could create
Yeah.
as many as you want.
Yeah, you can
I want
If
to
you draw
basically,
like 2 lines through, you can make like 4.
I can make even a lot more.
Yeah.
Correct? I could split this up again and again and make infinite triangles. That's a
Yeah.
good point. But what if I said only triangles from one vertex?
Yeah.
Right? So from one vertex, I can do this, and I can't do anything else.
Yeah.
Unless you can
So we
curve
have one triangle here, we have 2 triangles
One,
here.
2, yards.
Okay. How many degrees per triangle?
180.
180.
Together it makes.
360.
So we have 2 triangles. That's 360 degrees in this particular quadrilateral. You know what's coming? 5. What's the shape called?
Pentagon.
Pentagon. Very good. Let's draw it. Using one vertex. I want you to draw as many triangles as you can. Take a second and do it. And then when you're done, I see everyone working good. When you have that, look up and see if you get the same number that I did. So, using one vertex. And when you're done, look up and see if you have the same number of triangles. How many?
3.
3. Do you see that using one vertex?
I do.
Yards.
2, 3.
I used a different vertex, but I still got 3.
Exactly. It's going to be the same every time. So that's 3 triangles. 300. Oops. 3 times 180, isn't it? 3 times 180. What is that?
540.
540. Sounds good.
I don't even know what you asked.
I asked 3 times 180 degrees. Thank you for clarifying. That's right. 180, 180, 180 times 3, 540 degrees inside this entire thing. Okay?
Yeah.
Let's do it one more time. One more time. What's this called?
Hexagon.
Hexagon. Drawing it. It's basically a nice way to draw a hexagon. You can draw 2 lines parallel and then sort of connect it like this little ruby thing.
It's kind of cool looking.
Yeah.
No.
Yeah, there's something harmonious about it. I agree.
Yeah, man. That's yeah, math.
Should cap off everything.
This is like a math triangle.
Okay, picking any vertex, see how many triangles you can draw. And I'll pick this top left one.
Quality at home is showing you up.
How do you know where that vertex is?
It doesn't matter which vertex you pick.
Oh.
It's gonna
Does
be
your
something
line
can
that you
think
draw
of.
have to connect to another vertex?
Yes, connecting to another vertex. That's not next to it, of course, because that would be a side, wouldn't it?
Be a straight line, yeah.
It'd be a straight line. It wouldn't really be chopping that hexagon up.
A 13 gone.
13 gone would be a 13-sided shape. That's right. How many triangles do you count now?
4.
4. All right, 1, 2,
19.
3, 4. 4 triangles. 4 times 180.
720.
720 degrees, and we
About
pause.
720.
And we ask ourselves a question. The question we ask ourselves, let's stand over here. The question we ask is, and please don't call it out yet, we'll take volunteers. What is the relationship between the number of sides and the number of triangles that are created by those number of sides? There's something going on. Wow, 4 already. Okay, let other people think. Whenever you have a certain number of sides, you automatically have a certain number of triangles. Okay, most of the room. It's all good. If you don't understand it, it's still okay. We'll take you in the back, legume, beans, and chickpeas.
2. There's 2 triangles.
Always 2 triangles? Here I see 4 triangles. I know what you're getting at.
Wait.
Come on now.
Well, I always lose 2.
That's non-yay math word.
Something to add?
Yeah, well, just like to clarify, kind of.
Yeah, he said you always lose 2.
You always lose 2, but every time, say you have 8 sides, you'll have 6
Yeah.
triangles in it. So for however many sides, you have 2 less triangles.
That's what he just said.
That's right.
Exactly. I was
So
just
we're going to call n the number of sides. We're going to call n the number of sides. So the number of sides
Can we call it F?
equals n. The number of triangles equals what?
J.
T. T.
Yay math.
M.
And what? Is it the same?
N minus 2.
n minus 2.
Oh. Oh yeah.
You're comfortable smack dab?
Yars.
Okay. So
Here.
the number of degrees in any shape, the number of degrees in any shape is automatically degrees in a triangle times 2 less. See what's going on? Do you see that?
That's what I said.
Right? So if you have 6 sides, that'll be 180 times 6 minus 2. That's 180 times 4. That's
Which
720 degrees. And this entire shape is 720 degrees. Put it in green here. 720. Okay, first exercise for you.
Tissue box.
Total degrees in decagon. So please try that now.
Decagon.
And then when you're ready, let me know by showing me your time.
Oh, wait.
1440, thank you.
180 times.
1440, very good. So if there's 10 angles, and what if I told you that they're all the same, hypothetically?
What?
What would each be?
They're all congruent.
What would each be? There's 1440 degrees.
144.
144.
144.
If I had my calculator out first.
Vocab time.
Yay!
What is the vocab word for when all the sides are the same?
Equiangular. Oh, no. That's angle.
Congruent.
Equiangular?
Equiangular is
No.
true. They all are all the same.
Yeah.
And equilateral.
Congruent. Congruent.
Equal reticular?
This is a really good guess.
Equiventicular?
Wow.
Whoa.
That's good.
That's a
It
gay
sound
math
like a-
class.
Sound like a doctor. Yeah.
Let's see.
Is that right?
Equiventicular. Please remember that word. That was awesome.
That was right?
No. I'm supporting you. I support you all.
Tissue.
It's actually a lot easier. When they're all the same, that's called regular. So it's a lot easier.
What?
Regular one.
Regular?
Yeah, regular.
Come on,
I
Matt.
was close.
Yeah.
They give you such a...
Equiventic regulation. Here's what's interesting. I want to show you something that strikes me as fascinating. Go to a hex. Put a hex on you. Okay. See, these are the outside angles, exterior angles. I'm going to ask you a question. If I
Whoa.
Looks like a razor blade.
spun this around, if I spun it around really fast,
Somebody would get it.
Really cool.
what would it look like?
It would just look like a circle.
It would.
Yeah, it would just be a.
It would. In fact, if you detached all these green angles, if you detached them
It
all
would still look like a circle.
and brought them together, it would create a full circle. It would create 360 degrees. So for any shape, including octagon too, which is really fascinating, we'll go to our stop sign.
You have to write stuff on it.
Okay,
In red, in red.
I don't have it.
Oh.
So let's just mess with life.
What?
Okay.
Someone's gonna
Any shape whatsoever, all of the outside angles, regardless of if it's regular or not, all the outside angles will add to how many degrees?
180.
Almost.
360.
360, because it makes a circle.
Yeah, I
It
don't know
makes
why.
a
it's
circle.
like-
So all of those angles add up to 360. So let me ask you, how many sides in a hexagon?
There are
1, 2, 3, 4,
Six.
5,
Six.
6.
How many angles inside a hexagon?
6.
4, 6.
Six.
Triangle.
All right? If there are 6 sides and 6 angles, how many angles are outside a hexagon as well?
1, 2, 3, 4, 5, 6.
There are. So each exterior angle in a hexagon equals. What do you say? Yeah, I'm asking you. What do you think each exterior angle would be? If you know that there are 6 of them, and they add up to what again?
360.
So tell us.
Wait, 6, 720? Right?
That's inside.
Yeah.
That's inside. I'm asking you about outside. And we'll kind of come back to that. We'll bring it back again. How many exterior angles do you count?
6.
6. What do they add up to?
360.
360. What's each then? There you go. Yeah, do it. Do it. Yeah, do it. Do it. He's doing this.
6. Wait,
Yeah.
yeah, 6.
What?
60.
60. 60. I didn't mean to put you on the spot, but you're right there. Can we talk about it again? 6, all the angles are 6? All the angles are 6? in total, and they add up to 360. So each of them must be 60. Does that make sense? Any questions about that? Is that okay?
Yeah.
Okay. 60, 60, and 60. Thus, what's the inside? What's the interior angle?
It's not like.
This is your specialty.
Oh, okay.
Your specialty. What's
linear
the
pair.
Making it.
It's making it a linear pair.
Making it.
120?
It is
180.
one-
120.
Together 180,
12.
120.
12 plus a 0.
120.
That's still 12.
Okay? And now remember about how to get all the inside angles. Remember that rule?
Yeah.
Let's do the inside angle rule again. It's
Oh, this is
180
Great.
times what minus 2?
And
And which is what in this case?
6.
6 minus 2 in this case is 180 times 4
One.
is 720.
Ooh.
Or you can get 720 how?
Adding them together, my bad.
How much is this? You're right, both
120.
times. 120.
120. They're all 120.
How many 120s?
6.
3.
4, 5, 6.
Very good.
And that equals 720. 120 times 6 is 720.
That's minus 2. Oh, snap.
Does that make sense? Did you see it from both sides?
Yeah.
Both ways you could do it from the inside way is all the angles added up is 720.
Yeah, because 120 plus 6.
120
Plus 60.
plus 60 is 180, that's right.
And then you just.
Or you could
roll
do
this
the
out.
outside and add all these up.
Right.
Or you could basically say, yeah, you can get the 120 and then multiply it by 6
Right.
in that way. So it's the same, it's 18 times 4 or 120 times 6.
Right.
All right. Last question of the day. You'll like this one. What is
The
interior and exterior angles of an octagon, or as some people call it, a go
side?
I'm getting confused. Of a
Go side.
A stop/go sign.
Octago.
of an octagon.
Octago.
Works for me. All right, raise your hand when you're ready.
And octago. Thank you.
Raise your hand when you're ready.
Grammatica.
What the interior angle and the exterior angle would be of an octagon. That's good. We
Wait,
may
that's
be
what I
coined
did.
it. Do you not know what to do?
I do.
You know what to do?
Wait, what was the question?
Interior angle and exterior
The
angle
Oh, can I say
of
it?
an octagon. Not yet, please.
Octagon.
Interior angle, and there's multiple ways to do this. I like that. I like this. Raise your hand if you like this as well.
I love
Yeah, a
it.
couple
As
people.
well.
Yeah,
I love it.
As well.
I love it.
because it's the smaller numbers, I guess you could say. Could you summarize this rule? What is this rule? What is 360?
360 is the total of the
Yeah.
whole degrees. The total of the entire circumference.
Around the shape, right? Around the shape. Are we talking about the total inside angles or the total outside angles?
Outside.
Correct. Total outside angles here, 60, 60, 60, 60, 60. All add up to 360. 6 times 60. All right? How many total outside angles do we have here?
10.
8.
8. My bad. 8.
10.
I got confused. I'm sorry.
Plus
No,
2.
it's okay. No, it's okay to make mistakes. It's okay. So yes, there are 8 outside angles. How do we get what each is? What? Divided by what? Go ahead.
Would it be 360 divided by 8? Which
Are we comfortable with that?
Very.
Yars.
Do you agree there's 8 outside and they add up to 360?
Yeah.
And you have to keep in mind, I should have said a regular octagon so that we know they're all the same. So this is regular now. Is that clear?
Yeah.
Yars.
And what is that you said?
45.
45.
Which means that all those are 45.
All the outsides are that, and then I heard it
35.
135.
135 degrees.
And then if I asked you follow-up question, could you get all the interior angles added up now?
Yeah.
What would it be? What times what?
135 times 8 equals 110.
You're in your calculator,
1080.
which is cool.
1080.
1080. You're in your calculator, but you missed. I was like, when you're like 135 times 8, I'm like going like this, and you're just buried in your. Here, take it now.
You just gotta remember that. Like,
No, just take it now. Take it now. Okay, received.
I don't know. Okay.
You don't know what that means?
No, I don't know.
He's giving you anonymous
I didn't know what you were doing, and then I realized.
He's giving you the
I was supposed
Take
to
it now. Take it now.
Oh god.
Any questions?
Yeah.
You're so bad. It's so funny.
So we did. I know. Space. We did inside angles. No, we did inside angles.
Yeah.
We did outside angles.
Yes.
We did definition of, what was his definition? It was like
Yeah, man.
equiverticulus.
Yeah.
Equidistant.
Equigil.
Equiticular.
Equiticulating verticals, or AKA regular, all sides the same. All right,
Echoventricular.
and that's pretty much it. We did outside is the 360. All right, you guys, give yourselves a hand. Well done. Happy summer school! Woo! Give it up for summer school!
Yeah,
Awkward ending. Let's do awkward ending before you hit record.
school.
Okay.
Okay.
Y-A-Y-M-A-T-H. Yay,
I'll
math.
see you later.
Go ahead, hit that.
Okay.